quicker way, somewhat quicker, to get to where you want to go. Now, most of us want to go here in math. They give the function to you. Then they like to know where is the max or the min. What is the max or the min value that this function takes on? What's the highest value that function takes on, no matter what you replace x by? What's the highest the y value goes up to? Or what is the lowest it goes up to? That's what they're looking for. In other words, they're looking for something we answered here. But look how much work it took us to get here. We had to complete the square. I erased all that. It took all that to get to here. Okay, so let's try to look at something here together and see if there might be a little shortcut here. Then I'm going to slow down and have you guys do practice with something on this. Guys, I think, you know what, let me erase at least this much. I'll leave that over there. For a reason. Okay. Here we go. Bear with me. You're going to be good, solid, and watch carefully, focus on this. I'm going to give you a function, but I'm going to give you a standard function. I'm not going to give specific numbers. I want to say, let's take this. And of course, I know the a cannot be 0. And let that be accepted standard for a quadratic, ax squared plus bx plus c, which we all would expect. Now, here's what I got to do to get to the shortcut. To get there, it's going to take some work, but after we get it, you may use it. Your professor's going to go through all the work to show you where it came from to derive it. What I'd like to do with this, with your help, is to complete the square. I'd like to complete the square. You have no numbers here to work with. You don't have a 2x squared like I had before the break. It's an ax squared. So tell me if I want to complete the square. Let's write this down. Here we go. Anyone tell me in step 1, and guys, I am going to write this as y is equal to. Y is much easier to work with than that f of x notation. That's step 1. What should I do in step 1? Because if I'm asking for completion of the square process to be done on this strange quadratic. Go for it.
Divide by a.
You got to divide by a. Exactly. I think I divided by 2 last time. Now an a. Look at strange already. You got to end up with y over a is equal to, be very careful here, x squared plus b over a x plus c over a. Same thing we did with numbers. That's step 1, correct. Step 2, what would you suggest I do now? That's much like what I did earlier before the break with numbers. Move the c over a over. Exactly. So guys, just have y over a. She is correct. Now as I move it over, we're doing that for a reason. We have those x terms isolated. So it's time for us to put a blank as I move that over and get ready for completion of the square. So I move that over as she suggested, and I'm ready to complete the square. Here's the issue. Usually, it's a nice, well-behaved number here that I take half of and then square to see what's required on that blank. If it were a 4 here, 4x, you take 1/2 of it, it's 2, square it, 4. If it were a 9, you take half of it, 9 halves, square it, it's 81 over 4. Usually it's a nice number, you just take half of it, square it. Well, I gotta do the same thing here, even though it's to b over a. I still gotta do the 1/2 business, which is b over 2a. So there's numbers. But then do what with it after I do that? Square it. That's b over 2a squared. Guys, that's b squared over 4a squared. That, if there's no mistake, let's hope there's not, that is what I need on those blanks. B squared over 4a squared. And here. Everyone with me so far? Looks a little strange. So far so good? Don't let me make a mistake, because if I make a mistake, we're gonna be in trouble. Is that good right now? Now guys, if you don't mind, I need the space. I'm gonna erase this right here where I took 1/2 of this coefficient and then squared it like we should do for the reason to square. And I put down the blank. Just erase that. Now if all that's been done correctly, can someone in this accelerated class tell me that right-hand side should be able to be written as a nice, perfect square? Twice. X plus.
B divided by 2a.
Love it. Gotta be. It's gotta be. Now, if you had the time, I wrote x plus, as he gave me x plus b over 2a times x plus b over 2a, you squared it, and expand it out, it will give you all this. You want to check it. There's my perfect square, much like what I had with numbers before the break. The other side, still much like what I did before the break. I think over here on this one, when I worked the one before the break, I had numbers and I put them together with a common denominator, if I recall. I gotta do the same thing on this one. I gotta come up with a common denominator and put those two terms together like I did the one before the break. Can anyone give me a nice common denominator that might work here to put these together?
4a.
Can we get, ooh, almost
4a squared.
4a squared. Now, this one has the 4a squared. So if I'm going to use that 4a squared for my common denominator, then that first one has to be multiplied by 4a. It has the a. And here, 4a. Squeeze that in. Now both those items, terms, are now over the same denominator. I do have on top here negative 4ac, bring that down, plus b squared. So that's right, negative 4ac plus b squared, looks right. And I still have my y over a out front, going right like that. And I still have this. Jeez. Watch me mess up on this being on the top of the board here, let's hope not. Now, step 2. Does anyone see a mistake yet? Ooh, watch out for mistakes I can make. Top of the board here. June, Mr. Park, watch out for my mistakes. I don't want to make a mistake. Step 3. Anyone tell me what on earth am I supposed to do now, at this point, that maybe I did before the break on the other? What may be coming up next? Go for it.
Take the square root of both sides.
Oh, not yet. I was tempted. She said, Professor, you gotta now solve for y. You gotta get the y by itself. Did I do the one that I did before the break? Did I eventually have to get the y by itself? In your notes there, did I finally get the y by itself in my process I did before the break? Yeah, I gotta solve for y. You gotta be careful. Now when I say solve for y, right here, so we'll know, you gotta get the y by itself. Rena, you're telling me, Professor, this should be moved over. Over here. That would leave at least that, and that would help me to get that y eventually by itself. Guys, be careful now. So I've got, over on the other side, with that, I've got x plus b over 2a squared. And if I move that over, I'll think it's, what happens is some sign changes. This will change to a positive 4AC, and that'll change to a negative. Anyone see that if I take that over to the other side, these two in the green here with change signs, they're still going to be over that same common denominator. Yes or no? Because it change signs, this becomes a positive 4AC, this becomes a negative B squared. So let me write it like this then. Plus 4AC minus B squared, all over that common denominator still there. Yes or no? Don't worry, make a mistake. Gotta solve the y. Karina, with your help, that leaves, at least when I move that over, that leaves this. Now what am I supposed to do now in the last step to get y completely by itself?
Multiply with that.
Thank you. Multiply both sides by an a, everything by an a. If I do, here goes, the a's will cancel on the left, that's what I wanted, I want y. Multiply the first term by a, Andrew, just place an a there, the special new, leave the other part just like it is. Squared. And the other part on the end, be careful, I'll place the a over there just to make sure. You're also multiplying that term by a. Anyone tell me what that would look like on the end? If I'm multiplying by a or maybe canceling something out, what would that look like? Anyone? 4AC minus what? B squared over what? 4A. One of those a's will cancel. Oh my goodness. Let's hope that's not a mistake.
I didn't really understand why it's minus 4AC brackets plus B squared.
Oh, that's right here.
Yeah, when minus is connected with C over A, so it's minus 4AC plus B squared.
Right here, we had that. You're talking about right
Yeah,
there.
but it's before A over, Y over A plus minus 4AC, instead of minus 4AC, not plus.
Okay, I'm trying to follow what you're saying here. Hang on. You're saying
Yes.
something when I put these two together with a common denominator?
Yeah.
And, okay, let me go back, and we moved that over, and then we found this to be the number that's required in the blank, we put these two together with a common denominator of 4a squared, did we?
Yeah.
Is that true? And then we get then this, I wrote that's negative 4ac, it had a negative sign here, plus b squared all over 4a squared.
Yeah, but why before all that plus? Y over A plus minus 4AC.
Y over
Just
a,
use it.
oh, I've got a plus sign here,
Yeah. Well,
right, oh, I just separated them, I see right here. I still have this right here together, down here, I just made a plus sign in between here to separate them. Is that what you're looking at, y over a plus that? That's what you're looking at, this right here, I just brought it down like this. And then plus, and I've tried to show that that's different. That makes two separate terms. Look what, if I'm gonna do a little test here, if we test something here shortly and it doesn't work out, we've got troubles. Okay. Everyone else with me though, or is there something going on? Should I be aware of something? Or is it okay? Okay. Now, Andrew, that strange thing there, let's hope it's all correct, all that algebra we had to do. It's now in this form. It's in this form. So can you, Andrew, tell the class, as long as it's a stranger, if I ask you to name the vertex like we did over there for that first one, based on what you see right now, this is my turning point, the vertex. Tell the class what, because I noticed over here, it was x plus 4, and I think we ended up with a vertex with a negative 4.
Oh.
Didn't we? Is that true, guys, or not? Okay, now I think we did through transformations there. So, Andrew, I don't want to put you on the spot, but you're going to give me some help over there. What do you think the first term would look like?
Would it be negative b over 2a?
Look at that. make sense? It is negative b over two a. Because over here, he helped me out with that, that's why I called on it. This one was x plus four, and finally, we did it through transformations, but it finally came out to be for the vertex, negative four. Wasn't it? It was a horizontal shift to the left, negative. Thank you. Now, here goes, we're hoping the next part, Arena, we're hoping that the last part's okay. What do you think the y coordinate looks like?
Would it also be the inverse of?
Now, well, let's see what it was. Here, it was
Up.
-6, and here it's -6.
Yes, it's negative 4ac.
Oh, you mean it stays like it is?
Yeah.
Oh, by the way, did it remain the same here?
Yeah.
I think I had a -6, and was it -6 again?
Yeah.
So this stays like it is then, doesn't change. So I think it's 4ac. Oh, boy, all this algebra here. All over 4a.
Yeah.
Jeez. Oh. Arena, I'm hoping there's no mistake in all that algebra we had to do up there. But now we have a formula to find the vertex of the parabola without going through completion of the square, unless you insisted, or I insist you show me completion of the square. Without this, without that, this, if it's correct, I can just plug in numbers and find where it is. Now, before the break, someone will remind me, the one I did all the way through completion of the square, which took forever, was f of x is equal to, I think there was a 2 there. Can anyone tell me what the other terms were in the one we did earlier? There's 2x squared what?
Plus 3x minus 2.
Plus 3x minus 2. Please, can someone tell me, in fact, I cracked this, can someone tell me what we eventually ended up with, for numbers, before the break, what was the turning point vertex on this one?
Negative 3/4 and negative 25/8.
Negative 3/4 and negative how much?
25/8.
25 over 8, 3 1/8, and we graphed it. Andrew, you may have helped us out. Now I'm saying, here we go. Now, can I look at this and not touch completion square? Can I look at this and go directly to this formula that we derived, plug in values, and find that vertex quickly? Look, the vertex would be, first, negative b over 2a. That's negative, b is 3, over 2 times 2, that's a. Is that negative 3/4? Arena, I'm getting nervous. This one, this, if I have no mistake, had better give me, ooh, Mr. Park, June, I'm hoping, this had better give me, what was the second coordinate from the one before, oh, here it is, negative 25 over 8. Here goes. 4. A up there is 2. C is negative 2. I'm getting scared. Subtract. B squared. All over 4 times A, 4 times 2. Oh. If that's not 25 over 8, we got issues. Guys, I see 4 times 2 times a negative 2. Is that negative 16? Subtract, when I square this, is that 9?
Yes.
Over 8. Oh. Isn't that cute? Isn't that cute? Now, you have a way to find the vertex, the turning point of a quadratic quickly. And in fact, I'll add something to this. You might find it a little bit even quicker than what I just did. This is nice here. With Andrew's help, this is nice. That's the formula. I applied it, and we got the same vertex we did before the break. So now I'm just jumping to a formula now that we have. Yes?
Will we be expected to have this formula memorized on the exam?
Oh, my goodness, yes. But here goes. Anyone anyone can memorize, I hate to use that word memorize in math, anyone can memorize, where is it? This. Negative b over 2a, negative b over 2a, negative b over 2a. Is that true? Anyone can remember that. If I'm at the airport and I see you are at the airport also at the same time, you come up to me, Professor Rand, how are you? I'm good. You recall a formula from for the vertex from the parabola? Oh, Miss Ramsey, my flight's taking off. I'm leaving. What is that? I want to hear negative b over 2a. Anyone can remember that. The one that bothers me is, really bothers me is, and sometimes I'll mess myself. It works. Is this one? I know this one. Negative b over 2a is no problem. That's easy memory. This one, you know what I mixed this one up with? The quadratic, where it says what? B squared minus what? 4ac is backwards. And sometimes if I do something fast, I'll write down backwards. Rather than 4ac minus b squared, I'll do it the other way. Therefore, there is another way to find, without the 4ac minus b squared business, a little bit quicker to find that second coordinate, in our case, a negative 25 over 8, without that. I like this though. Here goes. Vertex. Yes, negative b over 2a. Now we'll throw it out here. Can anyone tell me what do you think might be a bit faster to find negative 25 over 8, the y coordinate, and maybe not, I like the formula myself, I can remember it, and not use this formula to find the y coordinate. What might be another way to do it? And that would be one less formula you have to memorize. Yeah, there you go, tell me again. Plug in that x value, and the x value was, my goodness, where was it back here somewhere? Oh, the one we're doing here. Plug in negative 3/4 back into my function. In other words, she said, Professor, don't remember that 4ac business. Just to find this, you do this. To find f of negative 3/4. Just take the x value back to the function, replace, I'm going to do it here. So that's 2 times the negative 3/4 squared plus 3 times the negative 3/4 subtract 2. Now we're hoping for a negative 25 over 8 to come out. Got to be careful. This is 2 times, when I square this, is 9 over 16. Minus 9 over 4. Minus 2. Let's cancel that 2 and the 16 out front, make that an 8. So it's 9 over 8. Guys, we're going to express everything over 8, a common denominator. 9 over 8, subtract, let's write this as 18 over 8. And maybe write this as what? 16 over 8. Is that right? Yeah. Would that give me altogether negative 25 over 8? This. Is that this? Yes or no? Therefore, if you don't want to remember this, where am I? This. Well, find this for sure, negative b over 2a, and then just plug it in as neutral. Now, that's nice. Very nice. Let's see if I'm ready for you guys to try something for me here so I can get those quizzes back to you. Oh, yes.